So good evening, everyone. We will start with the next module today, that is a deep learning. Okay, so it's just a subset from the machine learning which works on neural networks. Okay, so actually there are three types for the neural network, that is ANN, artificial neural network. Second is CNN, convolutional neural network, and last one is a recurrent neural network, that is a RNN. So three types of a neural network are there right now. So when your data is very large, okay, for higher large data, or when it is a big data, large data or a big data having large amount of like wide variety is there, high speed generation data is there. Okay, so if velocity is very large, velocity, that means the speed at which data is generating, volume is very high. Okay, data volume is very high, and having variety of a data, images are there, text file are there, PDFs are there, audio files are there, videos are there. This type of data generally we call it as a big data. So whenever there is a very high amount of a data, we are moving with ANN, artificial neural network. If our data is image based or video, image or video based, then we are moving with C, when we are moving with CNN. And if it is a like text data where we are working with a chatbot or like that, where we need to consider the sequence, key number of sequence are there, and it should have some relationship between the sentences. So that time we are moving with a recurrent neural network, which will have like a sequential transformer or sequential working will be there. So each neural network has its own feature. So first of all, we will move with artificial, as like we will move further or moving forward, we will go with CNN, RNN as well in deeply. Okay, so today we will just start with the first neural network, that is a ANN, artificial neural network, which it just means like is a computational model inspired by the structure and working of a human brain. So basic principle behind it is just like structure and working of a human brain. So our human brain is giving us the output, right? Suppose simple, if any hot surface is there, right? If any hot surface is there and we are putting hand on it, simple. So as soon as we put hand on a hot surface, what our brain is sending a signal, just take that hand backward, correct? So those signals are passed through the something that is called as the neurons in our body. So neurons has been activated and our brain is sending a signal, just take a hand outside or like other side. Is it okay? So that way it is work. So different layers will be there in a neural network, like input layer, hidden layer, which will be like composed of neurons, just like in your body or like human body or biological neurons. And it consists of interconnecting processing units. This neural network, artificial neural network, is consist of interconnected processing units, that is called as the neurons there, that works together to solve the complex problem. For very high dimensional data, it works well, and it learns from the data by adjusting the connections or weights between the neurons during a training. So whatever weights those has been used during a training for like initial phase, for today or tomorrow, it may be little bit challenging, but you will get familiar as soon as we complete the RNN. Okay, as soon as we complete the all neural network types, you will get good idea about how weights are working, how neurons are working, and what is the like actual process. Okay, so it is widely used in machine learning and artificial intelligence for a task such as image recognition, speech processing prediction, or a classification, any type of a problem. So whenever there is a large amount of data, high amount of data, we are preferring this neural network, that is artificial neural network, which is capable of identifying the hidden patterns and relationship in a large data set. Whenever you are having a data in a million, we need to go with a neural networks only. This is in like study from very earlier, okay, from 1960 or like 1970 it is having there. But when big data is generated, when more amount of a data is there, from that time it is used in actual practice. Is it okay, guys? Are you getting things? I'm not hoping like you will get everything whatever we are covering today, but at least you should cross 50% or something like that, whatever we are discussing. Is it okay? Obviously there will be some doubts, those will come forward after some time, so we'll try to work on that. But right now, whatever I am discussing, is it okay?
Yes, sir.
Okay. So this is just historical things for the ANN when it comes into the picture, just for your idea. Nobody will ask you this history. Nobody will discuss this history with you during an interview or whenever you are actually working. But at least you should have the idea when, from when it is there, right? We think like suppose neural network is like latest one or like advanced one, but it is there in a study. It is there in a, like a research papers from very earlier period. Okay, so 1943, wherein like and Walter proposed the first neural model or neuron model there. 1958, 1960, 69. Some limitations has been like overcome with a perceptron that was identified in 1969, right? So again, back propagation were introduced there in 1980 for which become very popular for training on neural models or like neural networks, right? For speech recognition, for handwriting recognition in 1990, ANN applications were expanded, right? In 2000, it increased the computing power and big data, which improved the ANN performance. Nowadays, it is widely used in every sector. Okay, so in every area you will find the application in deep learning, in robotics, in healthcare, or like even in finance. In every AI system, we will find application for it. So generally, in a resume as well, we will try to include the projects based on the deep learning only on ANN and CNN with the TensorFlow or like with the Part-1 or Keras. We'll try to include the projects there. Okay, so this is just a little bit theory about, like, sorry, history about ANN. And if we compare the biological neuron with artificial neuron, okay, so we just discuss it works as a biological neuron only. We just take an example of a hot surface and whatever signal that is sent through the neurons to the brain, and according to that, the action is taken, right? So where biological neurons has been found, so it is found in a like human brain and nervous system. Simple, right? In human brain and nervous system, you can find the biological neuron, and artificial neuron is found out. Both are like work similarly, but words are different. Biological and artificial. Biological neuron receive the signal through the dendrites. Okay, just like human body, we can say, right? Dendrites, and which receives the signal through the input data only. Okay, so there will be a layers, input data, hidden and output, like that. Cell body processes the information in a biological neuron, and mathematical functions are there. Suppose sigmoid function is there, other types of functions are there. Those will be used to process the data. Again, in biological neuron, action sends the output signal. It, in artificial neuron, it just produces the output value, right? In a biological neuron, it learns naturally through the experience, right? Hot surface there, just take a hand outside like that. It learns through the training algorithm. Same structure will be there. We will have some training data. We will test a model on it, and this will be used for the validation. Same thing will be used for the validation as well. Okay, so electrochemical signals are there for working with a biological neuron, and electrochemical signals in a biological, whereas in artificial neuron you will find a numerical values are there. Obviously biological neuron is very complex and adaptive. Simplified complete computational model is given with the help of artificial neuron, like that. So for biological neuron, you are having application in a biological intelligence. For artificial, that we are going to use in artificial intelligence and machine learning. So this is just like little bit comparison in between biological neuron and artificial neuron. So that's about like a comparison. If we check the structure of artificial neural network, this is very important, guys. Okay, what is there as an input? What can be the output? So simple. We will try to understand it with the help of iris data. Yes, how many inputs are there on there in iris data set?
3.
3 inputs, 3 or 4. In iris dataset, iris flower dataset,
4,
how many
sir.
inputs?
Sepal length, sepal width, petal length, petal width. 4.
Correct. Sepal length, output is a 3.
Sepal
Sepal length,
width,
sepal
petal
width,
length, petal
petal
length,
length,
petal
petal width. We will take same. Okay, 4 values are there, and setosa, versicular,
Versicular, virginica.
3 outputs are there. Virginica, right? Versicular, virginica, setosa. Okay, so we will provide the whatever inputs values are there in an input layer. Weights will be assigned by the model. Weights will be assigned by the model, and again it will have some bias. Again it will have some bias. This B1, B2, B3 represent the bias on a hidden layer. In between layers will be there. So as of now, just remember there will be always one input layer and one output layer. There will be always one input layer and one output layer, where input layer receives the input data. Sepal length, sepal width, petal width will be provided on an input, and output layer produces the final result or a prediction. Which type of a species is there? Whether it is output 1, output 2 or output 3, that will be given on an output layer. So in each neural network, in each artificial neural network, there will be always one input layer and one output layer. Whatever are in between, that is hidden layers there. That is hidden layer there, where data is being processed. So it performs the computations and extract the features. Okay, what is the output? That extraction will be there based on this equation only. Y equal to, what is the equation? First line of equation is y equal to mx plus c. Mx plus c, where y is the output, setosa, versicular, virginica. M is a slope. X is the input values. It will be like m1 x1 plus m2 x2 plus m3 x3 plus c. So m is a slope, x1, x2, x3, x4 are the input values, c is the intercept. So this is in case of a machine learning, linear regression suppose. In this case, in neural network, this will become y equal to wx plus c. Sorry, wx plus b. Wx plus b, where w is the weight that is assigned to a input value or input variable, which is important based on the like weightage, and b will be a bias. B will be a bias. Why this b is added? Just like an intercept. If weight is initialized as a 0, just remember this. If weight is like accidentally initialized as a 0, so there should be some output value for x, right? Yes, are you getting this? Suppose this equation is like this, right? Wx plus b. Why this bias is there? Suppose we are just predicting a salary, correct? We are just predicting a salary. Suppose weight is initialized as a 0 for 3-year experience, and this bias is not there. What salary will be there? 0. So to avoid this situation, what is added there? Bias, just like an intercept. Clear? So equation is just reformed over here in a neural network. That is a y equal to wx plus b, where w is a weights. Those are initialized just like a slope. So those are initialized by the model itself. Those are initialized by the model itself. That is determine the strength of a connection. So how connections are built in between the features. So these neurons are representing the features. These neurons representing the features, and in between how many neurons we want, that we can give. Suppose I just want a 32 neurons, so it can create a 32 neurons on a first hidden layer. I just want 40 neurons on a second level of a hidden layer, so HL2. Hidden layer 2 could have 40 neurons there, 40 inputs, and again those 40 will be converted to a 3, which will give you the single output. Okay, so just remember right now what we need to remember: one input layer, one output layer, one or more hidden layer may be there. And on hidden layer, we are having two values combination, that is a W and B. Optimized values of a W and B will be find out in order to predict the Y. Is it okay? Same as like Y equal to mx plus c. Is it fine?
Yes, sir.
Okay. So connections, those are like these connections that is we have given. Each neuron is connected to a next level, 1 to 4 connection, all these things. So connections between the neurons and weights will be there. Weight, that is just determining the strength of a connection. Bias is add extra flexibility to the model. If a bias is not there, some of the times you will get a 0 output, even though input is there, correct? and activation function that introduce the non-linearity in the model. So different activation functions are there in order to get the output. Okay, so some of the times a categorical value will be there, binary classification just like a true or false, yes or no, diabetic non-diabetic case may be there. There may be a like multi-class classification just like iris, setosa, versicolor, verderica. We just need to predict a single value among the three, correct? So what will be the like overall working for the ANN? Overall working for the ANN, that is the first step would be input data is given to the input layer, data is multiplied by the weight. What is the input data? X1, X2, X3, X4 suppose, right? Which is multiplied weight, W1 X1 plus W2 X2 plus W3 X3 plus W4 X4 plus plus B. Then it is applying the activation function. We need to activate those neurons, right? Whenever we are putting a hand on a hot surface, what is activated? Neurons has been activated. If neurons are not activated, we will not take our hand outside or like backward, is it? If a surface is a cool, whether we are taking a hand backward, no, right? So more weightage is given to that hot surface as an input, correct? What is the input over here? Hot surface. Hot surface is the input. That's why we are taking a hand outside, is it? So activation functions are applied. We will take what are the activation functions are there, what is the use of it, right? So WNX1, then activation function, information passes through the different hidden layers and final output is generated as per the like whatever data we are having, how the model is learning, how model is trained, based on that we are getting the output. Is it okay?
Yes, sir.
Is it okay? So this is how, just like in summary we can say what is there. Input data collection, X1, X2, X3, Y3, whatever values are there, that is given to the input layer of a network. So if somebody asks you what are the layers in a neural network, how many layers are there? There are three types of a layer, which are
Input layer,
hidden layer,
output layer.
input and output is always one only, and it can be one or more. Clear? Then after input, there will be one weight assignment, which weight is more there. So weight assignment, each input is multiplied by the weight that is initialized by the model to determine its important. Summation of weight and bias addition will be there. How? W1 X1 plus W2 X2 plus W3 X3 plus bias. So weighted inputs are added together with a bias value. And activation function, that function process the result and decide whether a neuron should activate or not. After activation function, it will be decided whether neuron should be activated or not. If hot surface, then activate the neuron. If surface is normal, there is no need to activate the neuron, and will be as it is. Yes.
Sir,
Everyone.
what is weight, sir?
Weights, that means which input is having the importance. We are taking some action, right? Why we are taking action?
Because
We are
its
taking the
neurons got
hand,
activated.
correct. So in order to activate those neurons, there should be some weight. What is the weight? Hot surface is the weight. If surface is not hot, that is like no weights will be assigned. There is importance to the input.
Level of
Which-
importance.
Correct. If more
Got it.
importance is
Thank
there, then based on that action will be there. So this, we need to like relate this with the biological things, and we need to understand this way only. I hope you are getting this, how it is, how it will work with a comparison with like biological neurons and all those things. Yes, Bhavya,
Yes.
Yes, sir.
everyone. Okay, is it going good? Saranya, Prema?
Yes, sir.
Yes, sir.
Okay, little bit, what do we can say? Right now, it may be a little bit challenging, but after some time, 1, 2, 3 days, if you are preparing the notes for it, if you are like going through the more material, obviously it will be like good for you. And we need to work on these only. Okay, we have to like go through it. We have to answer the things related to this. Okay, so activation function just processes the result and decide whether neuron should be activated or not. So hidden layers are there. Those will be used for the processing, which passes through the one or more hidden layers for a feature extraction and learning. What will be the learning there, right? We are just predicting y equal to, right? y equal to w1 x1 plus w2 x2 plus w3 xt, weights and input values are there, plus bias. So suppose setosa is, suppose what is predicted setosa, but actually it was the versicular, so error is there, right? So that learning will be there. We will just check the accuracy after working with it with a different hidden layers, number of hidden layers, and output generation will give you the processed data. Output generation will give you the processed data, reaches the output layer to produce the final prediction. Okay, so in a learning process, ANN will compare the predicted output with the actual output. Same thing will be there, like principle is the same. Just compare your actual value and predicted value and adjust the weights to improve the accuracy. Obviously, if setosa is predicted, and it should be it should have like versicular there, right? So what should be changes? What should be changed? X1, X2 values will not change, right? What will be changed? What will be updated? Weights will be updated, correct? In order to predict the correct value. Yes. In order to find the correct answer, what will be changed there? Weights will be changed. What will be updated? Weights will be updated. So there is something called as the weight updation formula. Okay, new value of weight will be given as per the learning rate, and all those things are there. So slowly we will move to that part. Slowly we will go through the like number of equations in this. But as of now, just try to remember input layer, output layer, right? In input, what you are having x, what you are multiplying to x, weight, what you are adding bias. After bias, you are just activating the neurons with the help of activation function. Different activation functions are there, like Sigmoid activation function is there, Softmax activation function is there. Okay, linear activation function is there in order to activate the neurons. Which type of output is there? What can be the output? Suppose binary in output is there, we will go with the Sigmoid. Suppose multi-class classification output is there, we need to go with the Softmax activation function. If a regression problem is there, we need to go with the linear activation function, like that. Okay, so we will see that part later, obviously. So these are some of the activation functions are there. Those are generally used. Those are generally used. So first one is like a step activation function. Simple. First one is a step activation function, which is just based on the like output is a 0 or a 1. Binary classification is there, which is based on the threshold value below 0.5 0, above 0.5 and equal to 0.5, that is a 1. So f of x equal to 1 if x value is greater than or equal to 0. Generally it is not used. So what is generally used? Sigmoid activation function and Softmax activation function, or sometimes linear activation function. Rectified linear unit is used. Okay, or sigmoid for a binary classification. Sigmoid for binary, either value will be 0 or 1. And Softmax activation function, that is a probability value. It is used for the multi-class classification. I will explain one by one. You will get a good idea. Don't worry about it. So for step function, it's just a 0 or 1. If a value is less than 0, it will be considered as a 0 only. Okay. If it is less than a 0, then value will be considered like negative values will be given as a negative values will have answer as a 0 only. If value is equal to 0 or greater than 0, then it will be considered as a 1. So two outputs are there, 0 and 1. Only one step output is there. So range will be either 0 or 1. So it is very simple and easy to understand. Not continuous values are there. And not a differential at any value of x. So it is used in a basic perception, but not regularly used. Which is followed? Sigmoid function is followed, which is just output values are in between. So it is not 0 or 1. It is in between 0 and 1. Equation for that is a sigmoid activation function, which is given with the help of f of x is equal to 1 upon 1 plus e raised to minus x. 1 upon 1 plus e raised to minus x. Actually, this equation is like this. Y is equal to 1 upon 1 plus e raised to minus mx plus c. What is this mx plus c? Is given with the help of wx plus b. Yes, wx plus b will give you the continuous output, correct? Yes.
Yes,
What is
sir.
output of this equation? Y equal to mx plus c. Y equal to mx plus c. That is a linear equation, correct? Which will give you the continuous value. We need to convert it into the either 0 or 1. In order to convert it into the 0 or 1, we need to use the sigmoid function, that is equal to y equal to 1 upon 1 plus e raised to minus mx plus c. I hope we have covered this in a sigmoid logistic regression. Is it, guys? In logistic regression, we have covered this, how continuous value is converted into the 0 to 1, less than 0.5 is considered as 0, greater than 0.5 or equal to 0.5 is considered as a 1. So these continuous values are converted into the categorical one, binary one, with the help of a sigmoid equation function. So smooth and continuous values will be there, differentiable at any value of x, used in a, this is very important, please remember this, sigmoid activation function. Please remember this line, sigmoid activation function is used in binary classification problem only. If it is a true, false, yes, no, customer churn, yes or not, diabetic, non-diabetic, cancer, yes, no, in that case, person survived or not, you can use the sigmoid activation function for a binary, and it can cause vanishing gradient. Vanishing gradient means sometime value of x like become 0. So value is not changing over the time. Weights are not updating. If weights are not updating, that problem is called as the vanishing gradient. So it may occur in some of the case, right? So that is a sigmoid activation function. If we are using a tan h activation function, so its output value will be in the range of each activation function is having its own feature. So for tan h, it is like range is -1 to +1, where we can have a formula that is tan h of x equal to e raised to x minus e raised to minus x plus e raised to x plus e raised to minus x. So for this range would be -1 to +1, zero centered output is there. Output is zero centered, smooth and continuous. Okay, better performance is there than a sigmoid in many cases. So if we have like a long range, if we need to consider negative values as well, you need to go with a tan h, but it is not regularly used. Don't worry about it. Most of the time you will deal with a sigmoid, ReLU and softmax. Sigmoid, ReLU and softmax. Okay. So next one, like fourth activation function, you just need to remember the names there. Okay. There is some echo, Saranya.
Okay, so 1 second.
So output 0 for negative values. If you want output for a negative value and input itself for the positive value. Input itself means if a value is a 0 negative, if a value is a negative, then output will be 0. Output will be always 0. And if value is a positive, output is a positive, it will be that value only. Okay. So for negative, it will be 0 always. So what is the simple? F of x is equal to maximum of a 0 comma x. If value is minus 5, what will be the output? 0. If value is 0 plus 5, what will be the output? 5 itself. Is it okay? Very simple. Maximum of 0 comma x. If value is a -5, 0 comma -5, which is the maximum one? 0 comma 5. 0 comma -5. Which is the maximum one?
0.
0. So output will be a 0. And if it is a 0 comma 10, what will be the output? 10 only. Correct? So it's computationally efficient, helps in reducing the vanishing gradient, like weights will be updated. It is not like weights are not updating. Most widely used in a hidden layer. Please remember this, guys. So ReLU activation function is used in a hidden layers only. For output layer, so there is no activation function on input layer, right? So activation functions are on hidden layer and output layer. So for output, it depends on the nature of output. For output, it depends on the nature of output, like which type of an output is there. If it is a binary output, then sigmoid function will be used. If it is a like multi-class classification, then it will use softmax activation function because it works on a probability. Suppose, what are the values? Setosa, yes, versicular, and last one is a virginica. You will get a value like 0.3, 0.4, sorry, 0.5, I will say 0.3, 0.4, and last one will be the 0.2. Now you have idea how these values are working. Maximum probability is if there are three classes. If there are three classes, so summation of all three classes probability will be always 1. Maximum probability value is 1. So which is the maximum probability over here? Versicular. The output will be a versicular. So if multi classes are there, right? For binary, what is the threshold? 0.5, correct? For binary, threshold is 0.5. For multi-class, obviously it will be a probability value. Whichever class is giving you the highest probability, that will be your output. For that, it is using the function that is a e raised to zi, each value exponent e raised to all the classes summation I equal to 1 to k. Number of classes are there. Range will be always 0 to 1. Yes. Minimum value of a probability is 0. Maximum value of a probability is 1. So output represent the probability. Sum of all outputs will be 1, which is used in a multi-class classification. So just remember these 5 activation functions there. Step activation, sigmoid, Tanh, ReLU, Softmax. Generally, you need to deal with the sigmoid, Softmax, and ReLU there, right? How it works? Sigmoid function is activation function used in an artificial neural network, converts input values into the output value signal in the range of 0 to 1. Whatever input value is there. So which type of curve is there? Logistic regression. We have already seen this. All continuous values are converted into the binary one, 0 to 1. So this equation is like 1 upon 1 plus e raised to minus x. Minus x, that is just a wx plus b. So this equation will give you the continuous values, and those will be converted into the categorical one with the help of this equation. So the graph of this sigmoid function is a S-shaped. This graph is just S-shaped. So commonly used in a binary classification problem, which will help in determining the probability value. Are you getting, guys? I hope you are getting this.
Yes, sir.
Yes, sir.
Yes,
Any
sir.
doubt till now?
So we have to remember all the formulas, sir.
No need to remember the formula, but please remember this one. Yes.
Logic.
Now you have y is equal to wx plus b,
Yes,
correct?
sir.
What is y? Output. What is w? Weights. What is x? Input value.
Input.
What is b? Bias.
Intercept.
Correct? So in this case, it will be a bias, correct? These values we are just replacing. By the time you will get, like in 1-2 days, you will get this formula. We are just replaced slope with weight and intercept with a bias. Is it correct? So this will give you the continuous output, correct? Suppose price we are calculating. In order to convert it into the binary one, what is the equation? Y is equal to 1 upon e raised to 1 upon 1 plus, sorry,
E power.
1 upon 1 plus e raised to minus y, we can say.
WX plus
So we can write this way, minus wx plus b. So this equation will convert all the values in the range of 0 to 1. And here you are applying a threshold. If this value, we can say p, probability value. If p is less than a 0.5, your answer will be 0. If p is greater than 0.5, your answer will be 1. Correct.
Yes, sir.
Yes, sir.
Done. Okay. So ReLU is very simple. Okay. Sigmoid and Softmax will be added on output layer. ReLU is used in the middle layers. That is a hidden layer. Okay. So the ReLU function is one of the most widely used activation function in a artificial neural network, which like output is a 0 for all negative input values and return the same value for positive, like just simple maximum of 0, x. So its full form is something like rectified linear unit, which will give you the maximum value, rectified linear unit. So ReLU helps in a neural network learn faster and improve the performance in deep learning models. Okay, it learns faster and improve the performance in deep learning model. So these are the some of the types of neural networks there, right? And like feed forward neural network is there, like input layer, hidden layer, output layer will be there. Simplest type of neural network. So as of now, just try to focus on simple neural network, which will have three types of a layer: input, hidden, and output. Input, hidden, and output. Output, you will have only neurons based on the categories. If it is like a cat or dog, 2 categories. If it is a setosa, versicolor, virginica, 3 categories, multi-class problem. So this is just the simplest type of a neural network. Data flows only in a one direction, single direction. No backward is there. no weights has been updated. Okay, so it is used for the basic pattern recognition and classification. If it is a CNN neural networks, right? Fast feed forward convolutional, that is the image based data is there. So mainly used in image and video processing, convolutional neural network. That is the second neural network we are going to see in a detail. Okay, we detect the patterns, edges, object. If vertical pattern is there, horizontal pattern, everything will be given, and which is used in a computer vision application. There is something called as CV2 applications. Just like a scikit-learn library, there is something called as the computer vision library. In that we will use this. Then there is something called as the recurrent neural network. Recurrent neural network. We can say this is the ANN, first one, fast forward. Is it just ANN? If a recurrent neural network is there, it will have a sequence. So it is used in a sequential data processing. Simple. So just give an example. If there is a red light on a signal, if there is a red light on a signal, person should cross the zebra, or a person should move with the zebra crossing. So there is a sequence between, there is some dependency of second statement on first. Is if first, like there is some relationship between the two sentences, correct? So there is some sequence for the data processing. Is it when person should cross the road or a zebra crossing when there is a red light? Is it?
Yes, sir.
Yes.
So whenever there is a need, just like this, we are working with this type of a neural network. That is a recurrent neural network. Most of the time we will work with the text data in this, which has a loops to maintain information. So it need to store, right? It should store when there is a red light. This sentence should be stored so that it can implement the next one. So there should be some memory which is applied in a speech recognition, language modeling, time series data, where it is considering the sequence and all those things. So it is a recurrent neural network. Next type of a deep neural network is there. Yes, DNN is there. Deep neural network. So these are the just types for the neural network. Yes. So we just covered the recurrent neural network, convolutional neural network is there, and deep neural network is there. That is a DNN. So what is there in a deep neural network? Like input values are there. We are having like multiple hidden layers. Like n number of hidden layers are there, and you will have in output there. So it's just like advanced part for the feed forward or FNN. Okay, which contains the, what is the difference? Multiple hidden layers are there between input and output. So it can learn the complex pattern, correct? It can learn the complex pattern and representations. So which is used in advanced AI and deep learning applications. Which is used in advanced AI and deep learning applications. Other types of neural networks are there. Those are used or not regularly used, we can say. Most of the time you will just deal with this is like more than sufficient. ANN, CNN and RNN. We will deal with these three types of algorithms there. So radial basis function network is there, which is like working on a radial base layer. And we are not having algorithms for this or not model. We are not going to train any model for this. Just like remember as a type of neural network there. Self-organizing map is there, which is just called as the SOM, self-organizing map, which is unsupervised learning for the neural network, which is used in a data clustering and visualization, which preserve the like topological properties for the input data. So which will cluster the data based on the similarity, just like a k-means or advanced things for the k-means. This is how it will work. Last one is like in high level AI applications, you will find this long short term memory network. That is short form is LSTM, long short term memory. So input values are there, then it will remember something, it will forget something, and output will be based on that. So it is a special type of a recurrent neural network or RNN. It is a special type of recurrent neural network or RNN, which is designed for the long-term memory applications. So which solves the vanishing gradient problem of a recurrent neural network, and used in the text prediction or machine translation like that. Okay, so time series forecasting. So what are the like important topics over here? ANN, CNN, RNN, deep neural network. So you just need to focus on these things: ANN, CNN, and RNN. And advanced part for the RNN is just long short-term memory. So we'll have some applications. We'll try to build a model on that. So please prepare the things for this, guys. Like what we have covered till now, we just went through the what is the ANN, correct? What is it like?
Yes, sir.
What actually ANN stands for? Then what is there?
Artificial neural networks.
Biological neuron and artificial neuron difference. What is the structure of artificial neural network? Input layer,
Hidden layer.
yeah, input layer, output layer, and hidden layer. There can be a one or more hidden layer, right, in between input and output, right? And just try to remember the process. What is there? We are providing an input, then multiplying it by weight, input multiply by weight, adding a bias activation function, then we will get output after processing. So just go through this working. What are the activation functions? Just try to remember the things for the or like feature of each activation function. At least you should have idea about sigmoid. So please go through these things, guys, till types of a neural network. We'll go move with like perceptron and all those things in a next session, so that we can complete all the theoretical part related to this about ANN, and after that we will go for the implementation of it, right? So that's all, guys, for today. Thank you.
Thank you, sir.
Thank you, sir.